for table design, and you have a dynamic process through the process flow diagrams, and you are developing the procedures for data flow and the comfortable running of the online system. So here in this online system, the advantage is any kind of query can comfortably be answered by you. That is how you have modeled the relational databases using the table data structure, and you have developed the comfortable stored procedures and a backend security mechanism. You have developed the database triggers, database stored procedures, right? And for front end comfortable data entry, you have devised the data entry screens, right? You have developed the different mechanisms on the front end to have field level validation, record level validation, database level validation. Lot of things you have developed. You have made the system very concrete and comfortable for the use, right? So when this kind of scenario took place, fine, people were very comfortable with that, and your online transaction processing was going. In this context, I would like to give a simple example of your online transaction process. Suppose you have a online transaction processing system for your college. What are the possible queries that can arise out of you? Some of you can say a number of students in a class, right? What are the courses offered for some specific class? Or a student wants to know what is my percentage of attendance in specific class. What are the internal marks I obtained, right? So these are all the standard queries you will get, right? So almost the kind of queries are fixed. Maybe the data will differ because the percentage of internal marks is a standard query. You have to get from certain table. If it is your roll number, for your roll number, it will be retrieved. If it is for a group of numbers, it will be retrieved for them. Or for any other individual, it will be retrieved. But the gen form of the query is the same, right? So if you look at it, the kind of queries you get in online transaction processing system are the fixed queries. Please note this point, my dear friends. What I am telling is, in future, we will be discussing with about online analytical processing. At that point of time, we say that the queries were ad hoc. Why those are ad hoc queries, I'll explain you little later. Okay. But I'm talking about your conventional database. So you will have fixed queries almost. So you will make query panels, you will make a lot of other stuff and make the things run in your online transaction process. And after this relational model, the object relational model, different multimedia databases, spatiotemporal databases, text databases, many other things have evolved. That is the next step of it. Why those things have come into? Because in early 60s and 50s, you don't have very good networking facilities. Right? Suppose in 50s or early 60s, a corporate company is there, located in United States, its headquarters. Suppose consider Colgate Palmolive. They have the headquarters in US. They have their business in Asia, Europe, China, Australia. It's spread across the globe. And suppose you want to know what are my business trends of my products in South India. What is the status of my products in Australia? They want to know. They have to communicate with these people. They have to get the data. They have to consolidate it, and they have to send it, right? because at that point of time you don't have any high speed network. But today, if you look at, you have availability of very high speed network. These corporate companies just take a leased satellite line of their own, and through the satellite link, all their offices will be connected. And as and when you just enter the transaction entry here, that reflects in no time into their central server, and head office will get the information in no, right? So these corporates generate a very huge data. Apart from that, if you look at the database relational model of 90s and up, it's basically just the numericals will be dealing with some numerical values or at most some of the character values and all. But you will be dealing with a structured data type. But even that structured data type concept has gone. What is the reason? You have very high speed networks, you have satellite things. So you are receiving a different kind of data from different sources. You will be receiving some signals from satellites need to be processed. You will be receiving images from satellites to be processed. You will be getting the geographical data. You will be getting the data across the map set. You have to process all. And your internet has become a very huge repository. So you have audio, video, text, whatnot, all kind of data with different kind of pattern. When the image has got thousand kind of form, signals of different form. You have a very heterogeneous tons of data flooded every second onto your head with a kind of highly heterogeneous nature. So it has really enhanced the complexity of the data to be. So that is how the evolution has been. And of course, latest you are dealing with the big data. Big data means you have to deal with this kind of heterogeneous, structured, unstructured, huge data. Let's say why you have to. Anyway, big data is not the topic for our discussion, but it has led to that. Why the concept of big data and other stuff has come into picture means when the data volume is abnormally high, your relational model will fail. Your relational model will even for your data mining applications also, you will denormalize the data. I'll tell you why and how you have to denormalize the data. So again, the concepts of your networking model, graphs, which you have thrown onto the dustbin, again you have to capture those things. As the network model, you almost stop. Because in 90s, I remember when I was studying in IIT Kharagpur, there was a network model system. NOS-VE was the networking operating system used on. That was the one using the networking model of answering queries and all. So that was there for quite short time. But subsequently, all those things have vanished because of the strength of the relation. Though the relational model is very strong now, it is useful only for online transaction processing to a certain level of data. Beyond that, that model fails. What is the reason for the failure of your relation model is the expensive nature of join up. Join operation is a pretty expensive one, and in order to answer any kind of query, the join is a mandatory operation. mandatory option. Without join, you can't run. Because I just tell you the complexity of join operation. When I was working in industry, a kind of scenario is we have to give the information about all the agents who purchased some insurance policy. Sorry, all the people who purchased insurance kind of thing. You have to give the differences who are there, who are the new arrivals into the system in past 1 month and who left the system in past 1 month. Kind of information needs to be. For that, you need to join 3 4 tables. So the typical size of those tables were 100,000 rows, 250,000 rows, so quarter million rows, 2,50,000, and 150,000. So the join operation means to get the time complexity is 100,000 into 250. And if you join another table, this 150,000 into 100,000 into another 150,000. So the complexity enhances. At some point of time, you will just hang up with the volume of the data. So it becomes beyond your operation. So in such case, you cannot go for a relation. The concept and subsequently I told you the data is heterogeneous. So the big data processing concepts have come. Now, what happened is, so these are the kind of evolutionary steps in data. When this kind of evolutionary steps are going on, now we will come back. This is the kind of thing. Why the data mining concept has suddenly come into the mind of people. That is, you are accumulating or piling up a lot of data. Suppose you are a departmental store, let us say. So you have a chain of 100 to 200 stores in a state, and you will be having some millions of transactions by end of. But how long you will keep the data? Till end of the financial year. What happens by end of the financial year? You will settle down your credit and debit accounts, and after end of the year, you will just have a backup and you will throw that into the cold store. So you will have a backup on the Mac tape that goes. Suppose the engineering graduates information, your marks, internal marks, your syllabus, everything. So that will be maintained for 4 years in the online system. Once you get your degree and you are out of it, that will be backed up and again put into the cold store. Now, if you typically look at the project expenses, they are pretty high because any company, any corporate company, if they want to implement a relational database or a kind of ERP model, they are ending up with a project cost of 5 to $20 million, $5 million to $20 million. That means ranging from 20 crores to 100 crores, 130 crores. That is the typical implementation cost of an ERP project for an organization. Because you'll be getting online information, you are processing the online information, you are getting the stuff. So you will get everything coolly and comfortable. Right? But having spent this much, this is the initial investment cost. After that, you have to maintain the programmers and the IT department and team, their salaries, everything. Even that expenditure is also pretty high. So any organization will look for a good return on investment. Okay, end of the financial, I'm just keeping the data in cold storage. That's all. Then if you look at the data after 5 10 years, you have several millions of records or billions of records. People thought at some stage, why not we use that kind of data? Is it not useful for us? See, in your industry, what is that you are doing? Suppose you are making paper. Okay. So you are cutting down the trees and making the pulp and running the show, right? After that, huge amount of paper is there and some other waste material is there. But what is that you are doing? You are trying to recycle the paper and use. That means you don't want to waste any kind of material, right? Similarly, if you are growing a crop, okay, the crop season is for 6 months. Remaining 6 months, you are planning for alternative crops, right? That is what for your resource is limited. You have to get the optimal product out of, right? Suppose you have grown a coconut garden in between lot of spaces. So you are growing cocoa or some other thing, some other product, black gram, green gram, or some kind of things you are having as byproducts, and you are trying to enhance the productivity. You want to optimize the productivity and get the maximum yield of it. That is the human tendency, and that should be the tendency. People thought we are piling up a lot of data, lot of stuff there. So in such case, can't we use this data for any kind of further enhancement? That was the idea that came into the mind. Actually, this is not a new idea. We people adopted this long back, but in a small way. Let us suppose you started a general store. What is that you will do? You will observe the neighborhood of the data. You will say, sorry, neighborhood of the your premises. So what kind of people are living? What are their interests? What are the buying patterns of those people? Right? And you will then analyze that. And from your past experience, okay, last year some stores was there. How much sale was here? What are the products liked by people around in this? So they analyze that. Accordingly, they purchase some stock and keep it. And suppose, of course, any other information is there, they will process it and saturate the stock, right? So they are doing the similar kind of scenario. Let us suppose they are staying in a colony wherein lot of employees are there. When lot of employees are there, what people will do? Okay, as many employees are there, actually husband and wife all are employed, they are going up. They are well earning in a well earning category. So we can sell some ready made food products. Right? We can sell some luxurious food, some packaged food can be sold. Like that, we will bring some sample stuff there, and then he will see the business for a month, how it is flowing and all. Then depending on that, next month he will adjust his stuff. Suppose he will buy 10 items. If they are sold in 2 3 days, then he will go for some more stuff. And he will estimate in the month how it is going. So once in a month, he'll buy in bulk. Okay. That means depending on the previous patterns, or somebody is doing a business in and around already, he will study his patterns. What are the sales aspects? What are his deficiencies? So that means it is called the knowledge discovery process. You will discover the knowledge, how to get the stuff, how to get the information, how to process it. So they go for this kind of knowledge discovery process. Okay. And then he will analyze the requirement of resources and he will buy the stock. So now, suppose in the departmental stores itself, you have the sales data transactions piled up over 5 years. Then what he feels is, okay, from this, let me predict how much stock I should maintain. A sales forecast can be done, not we do. Let us have a sales forecast. So he will think in that fashion. So how to do that? Sales forecast. So your input data is your transactional database data. That is their state. That means your point of sale transaction data. So how it appears like your point of sale transaction data? Point of sale transaction data appears like, anyway, I don't have the whiteboard facility, but tomorrow I'll arrange for that. It is like your bill. Suppose you go to the departmental stores and if you get the bill, what you will have? The name of the departmental stores, date, time you will have. Then you will have item name, quantity, unit price, total price of some whatever items you purchased, 5 or 10 items in a line. Then under that, the total bill amount, right? So that is your point of sale transfer, right? That bill. So in that, a single entry is an elementary transaction. బోర్డు గురించి ఇప్పుడు వరి చేస్తే చేయండి. So one row is a elementary level transaction in your point of sale, right? So taking that into consideration, if you sum up all the point of sale transactions for each and every item from 1st of this month to 30th of this, what is you will get? All the bills purchased in 1 month. Okay. So you have all these bills at your disposal in your hand. Now, from every transaction you said, yes, from this bill, 50 kgs of rice, 10 kgs of sugar, 5 kgs of wheat, 2 kgs of oil. This is it. And from another one, it says, yes, 20 kgs of rice. Another place, 30 kgs of rice. So if you take all rice transactions from all the bills, you take all sugar, that means item wise, you segregate the transaction and you sum up those transactions. Then what is that you will get in such case? In such case, you will get item wise the total quantity sold in a specific month, right? You do it like this for every month. What is happening then? You will get the summary of, that means in January month, summary of rice, February month, summary of rice sale, March month, rice sale, April month, rice sale. Like that, you get the so your point of sale transaction. Uh, my dear students, is it visible to you? You please tell me. If it is not visible, you please raise your hands there or so your point of sale transaction, the bill will be like this, right? 50 kgs and the unit price. Okay. Total. And the end you will have. Okay. Is it visible to you? I don't think. Huh? There is a problem with marker anyway. I'll replace the marker. But at least I think you will have a broader picture of it. Please respond, my dear friends. Is it visible to your? You're not able to see this anyway. Anyway, I'll try to correct it by tomorrow. So now what I'm saying is, at least you have a broader idea of how the receipt looks like, right? Now what I'm saying is, in the month of January, from 1st to 31st, I will add up the quantity sum and amount sum of all the transactions. Okay. Then what I will have is, I'll get the total amount of rice sold in January. Similarly, the total amount of rice sold in February, March, like this. So once I get this, I will have this for this year. I will have the similar kind of transaction sales of last year. 2015, the sales is this. 2014 sales I will have. 2013 sales also I will have. Then what I can do is, okay, the rice sales in 2011, what is the rice sale? 12, what is the sale? 13, what is the sale in month of January, in month of February? And similarly, I can have the quarterly sales of the items. So once I get this kind of thing, I can just have a clear cut analysis of it. Okay, in 2011, the total sale in the month of January is 5,000 kgs. In 2012, it is 5,500 kgs. Afterwards, it is 6,000 kgs. Let us suppose after that it is only 4,000 kgs. Now, then you will analyze, okay, how the sale is there. Why there is a reduction in the sale? Why there is an enhancement in the sale? Because you will observe the parameters at that point of time. Okay. Suddenly there is a fall in the sales in 2012. Let us suppose for onion. The onion price went to 100 rupees a kg. Let us. So that one the quantity sales will be less. You have to consider the quantity and amount also. Amount might be more because instead of eating, normally the price is 15 rupees kg. Let us suppose if it becomes 100 rupees kg, instead of buying 10 kgs, you will at least buy 1 or 2 kgs. So you incur spending more. So if you just look at the amount sold, you will not get actual prediction. You have to look at the quantity sold also. So these are two parameters that influence total stock. Okay. So you have to analyze why this has come into picture. Then what they will do is from this trend, okay, this year how the trend is going to be. Is the crop more? Are the people interested in this product still? So suppose there are a lot of other varieties substitute for a product have come into market means the sales of this product will automatically go, though its price is much lower. Suppose you had a better alternative products which people are liking, right? See, 10 years ago, the manual rickshaws were there. Okay. So many manual rickshaws were there. But once the autos have come and occupied, automatically the manual rickshaws vanished. Though he says, person for some competition, they say the auto fellow asks for 10 bucks. He says, sir, give me 5 bucks, I will take you. But still, you will say, no, 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 my time will be wasted. Don't mind. We'll go by auto. At some point of time, he may not afford to reduce the price. So for 10 rupees, manual rickshaw is there, for 10 rupees, auto is there. Manual rickshaw will take 15 minutes and this will take 2 minutes or 3 minutes. So you will automatically prefer. So like that, if any new product comes or there is a change in scenario, then the product sale might come down or might enhance. Okay. Because now the biodiesel is being extracted from some leaves. Okay. Long back, some 10, 12 years back, if you look at that, that crop was there, some seed, I don't remember the name of it. It was hardly there in few fields and only the animals were using it as a feed for short time. Then they found that the biodiesel is available from that. And immediately, similarly, you'll have some leaves. Suddenly, let us suppose that that leaf is very well useful in the treatment of AIDS. Immediately, its price enhances by 50 times or 100. So, many factors will be there. So, if you have this kind of data at your disposal, yeah, you can make a trend analysis of that and you can extract a better knowledge for a better running of the system, because any system is to be optimal. Suppose if your demand is 100 kgs and if you keep only 50 kgs, you lose the profit for 50 kgs and you lose the credibility in the market that you cannot supply the item. So with that idea, if you procure 200 kgs, it is a loss for you. Only 100 kgs will be sold. Loss of inventory, loss of space, loss of expenditure incurred and all. You might have seen the products will be there on sale for Christmas and some other festivals, Sankranti or Dasara and all. What is that they do? Any stock that is piled up for a long time, they will give you 50% reduction, 60% reduction and sell it off. Okay? Because they make more profit when the product is damn fresh. In Paris, if you look at, it's a fast changing fashion scenario. So a latest fashion item, though its production cost is 1 or 2 euros, they will sell it for 100 euros. So because of craze, people will buy for a short time. And once the craze is down, craze has gone, they will sell it for 50 euros, then for 20 euros, and finally in the clearance sale, you will send it for 2 euros. Because they make the profit in the very beginning. So depending on these trends, they fix up the pricing. Similarly, your airline tickets, if you book 3 months before, you will get for 10,000. After that, you will get for 15,000 or something. Suppose your travel is tomorrow, you'll charge 40,000. And sometimes they will observe the trend. Suppose the seats are not filled even 2 days before. Then on the last day, you will drastically reduce the price. So they will have different models for pricing the ticket. So how this is being done? For this, your data warehousing and mining concepts are being. Okay. So this initial process is called the knowledge discovery process. So that means you want to extract some useful patterns out of the existing data. Okay. So as a part of this knowledge discovery process, The remaining steps have evolved. Okay, you got the idea of this, right? So, can you put some questions to me on this? Anything about your understanding and all? Can you say something from your side? And just interact. Say something about. So today till now, not today, till we are going to cover, we just covered what is the technological evolution that took place in the database area and why the knowledge discovery process is popular because this process they never thought of before because they don't have accessibility to use data. ఓకే దగ్గర చెప్తున్నారు అదేమైనా వస్తుందా వాళ్ళ నుంచి కామెంట్ ఓకే ఓకే సెట్ అయిపోతుంది సో the scenario is because very huge data is possible now because of the scientific advancements and all, we thought from this very large volumes of data, we can discover certain use patterns that are helpful for enhancing your system. That was the broad idea. Okay. Now you run the slideshow one by one. So in the introduction, you will see what is data mining, then a multi-dimensional view of data mining, what kind of data can be mined, what kind of patterns can be mined, what technologies are used, what kind of applications are targeted, major issues in data mining, a brief history of data mining and mining society, and the summary of it. So this is what we are going to briefly look at next. So why data mining? Just of course we discussed the explosive growth of data from terabytes to petabytes, data collection and availability, automated data collection tools, database systems, web and computerized society. This is generating you a very massive data. And the major sources of your abundant data are your business, web, e-commerce, transactions, stocks, okay, and science, remote sensing, bioinformatics, scientific simulation, and society, the news, digital cameras, your YouTube videos. So these are all the different sources that generate terabytes of data. Okay? So we are drowning in data but starving for knowledge. So NASA is a mother of invention. So the data mining automated analysis of massive data sets. There is a concept, that's not the exact definition. Through data mining, what are these steps I will explain. Okay. So here I told you the shopkeeper example. That is the data mining done by him inherently with his talent and with his experience. But now you have tons of data here. You have to have a massive processing of it. You have to automate that process to extract the knowledge. So that is the challenge that is thrown before you. Okay. So from this massive data set, it is needed to extract. So for each kind of data, you will use a variety of. Next slide. So before 1600, just empirical science. 1600 to 1950s is theoretical science. Just we discussed the remaining things. 50s to 19s, computational science. Most disciplines have grown a third computational branch, empirical, theoretical, and physical. And computational traditionally mean simulations, it grow out of inability to find closed form solutions for complex mathematical models, because you're not having solutions for very large complex things. Okay. And 90s, your data science, floods of data from new scientific instruments and simulations, ability to economically store and manage petabytes of data online. Because what has driven you to go for knowledge extract processing, and the internet and computing grid that makes all the archives usually accessible, and scientific information management, acquisition, organization, query and visualization tasks scale almost linearly with the data volumes. So data mining is a major new challenge. So got the idea? Because of your scientific invention, you have several petabytes of data flooding due to these reasons, to economically store and manage petabytes of data online itself. You know pretty well your Twitter, Facebook, just in an hour it generates several petabytes of uh, petabytes of data. If you just look at typically the Walmart data generated is of the order of 2 petabytes. So with your latest sequential processing systems, if you just want to read that and store the data on the server, that itself takes more than 20 hours to load it. Because any shop is there, what will be his idea? Okay, today how is my sales position? So tomorrow how can I adjust the sales? Because what these sales shops they do is, even they employ temporary people on hourly basis. Suppose 1 to 2 is the lunch hour in the organizations nearby. That between 1 and 2, how much extra sales is needed, he will forecast. And he will employ those many part-time people for that hour, paying some $20 per hour. For that sake, he need not hire a regular employee and pay him a minimum wage of $2,000 a month or $2,005 a month. That is the minimum wage if you employ anybody on a regular basis. Because for him, only daily 1 hour job is there. So you don't do that. Instead, you hire an unemployed people. Some 5, 6 people, you hire them at $20 an hour or $10 an hour. Keep them near the counter. Just pay him the amount once he is done. Job is over. Not run payroll for him, you not pay social security for him, not pay taxes for him. And the overhead of maintaining all the stuff is not there for him. So he thinks, yes, today I need 5 members. Because the volume is more as per expected. Tomorrow I may need 10 people. So that he will understand from today's analysis. So for that, what is needed? By end of the day, you should get your daily summary data. But the data is so voluminous that just to summarize the data of today, that itself takes 20 to 30 hours. Then when you will get this answer for this? Because by tomorrow morning, you should know how many people you have to employ. But to analyze that, the data takes 2 days for you to summarize. Then what is the use of it, right? So if you just have a massive data accumulated you, from which you can predict the results accurately, no doubt about it, but you cannot process it within a stipulated time, it's of no use for you. So that's a challenge there. Got my point? So how to do that? So there are various techniques, summarization technique and all that. You will come across. So that is a kind of major challenge. So 60s I said data collection, database creation, IMS and network databases were there. And 70s relational data model, just we discussed all these things. 80s RDBMS advanced models, extended relational, object oriented, deductive, etc. And application oriented DBMS are there. Spatial scientific engineering. I tell you one thing in your databases evaluation, because especially in data mining, you will come across spatial data mining and temporal data mining. These are the two concepts needed, and web data mining. Web mining means in the web you will have different multi-dimensional resources, and you have to mine the knowledge or extract the knowledge from them. Okay, and as far as the spatial data is concerned, means you get from the satellite the pictures, the roads, the fields, and other stuff. Okay, so from this, what you will have is the spatial database means the location, the space plays a prominent role. So map is there at this point. Suppose this is the city Kakinada. In Kakinada, okay, how the poverty levels are varying. So what conditions are influencing the poverty level? What situation is influencing the salary level? Similarly, at sea coastal place, how sudden information is going on. So depending on the space, the position is a important point there. Based on the location, you have to mine the data. So that's called spatial data. And another thing is important thing is temporal data mining. Temporal data mining, time is a very important factor. Suppose stock analysis, stock predictions. Their time matters very much, right? Every half an hour or 1 hour, any small thing can influence the price of the stock, right? Suppose the oil stock is there. Oil is sold right now at some $46 per barrel. Let us suppose the Islamic State crisis has increased, and let us suppose the United States, France, and UK, they declared a war in Gulf, and they want to attack all the military bases and oil reserves of Islamic State. Let us say that has been declared. Immediately, your barrel oil will shoot from $50 to $100, right? So immediately there will be a change in stocks or whatever. So the some prices will go pretty high, some prices will come down. It all depends on the kind of. Suppose the economy is strong and going, US economy is getting stabilized and all. The gold price will come down. Last year you have sold gold for 30,000 per 10 grams. Now it is 26,000 per 10, right? So that is how the prices alter based on it. So here, what is the important factor? Time is the important factor. So that kind of data is called temporal data. So you will have an analysis of that kind of temporal data. It's called the temporal data. So these things have come into picture, and because of the complexity in business and the volume of business that is happening, you got the object oriented database models, extended relational data models to incorporate certain complex business logic. All these models have evolved. If you go for an object-oriented model, your maintenance cost will be less. Initial investment on object-oriented models, initial base cost is high, but it is worth it for the long run maintenance. Okay, so that is the kind of thing. In 90s, you have got the data mining, warehousing, multimedia databases, web databases, and in 2000, you have stream data management and mining. Data mining and its applications have become vast. Web technologies, your XML and data integration, and global information systems. You have a lot of GPS data available, right? For global positioning and movement. There's tracking of items and the traffic flow, traffic prediction, and various things. Next. So why data mining? What is data mining? The second point we are going to study. Data mining, what is this? He says extraction of interesting, non-trivial, implicit, previously unknown, and potentially useful patterns or knowledge from huge amount of data. What are the alternative names? They are knowledge discovery, ADD process, knowledge extraction process, data pattern analysis or data archaeology, data dredging, information harvesting, business intelligence, etc. are multiple alternative names used for this. Is everything data mining? Simple search and query processing or deductive expert systems? Are they come under data mining? I tell you one thing, he has just considered data mining and knowledge discovery as the same in this slide. But actually, as per the textbook of the same author, data mining is different, knowledge discovery is different. How is it different? I will explain. Okay, just look at the diagram, then I will explain you how the things are there. See, I told you your data is, the origin for your data is the online transaction processing system. That is your day-to-day running database management system that is in place used for automation of some business process. Do you agree? Now, this is a view of typical database system and data warehouse communities. I'll explain you what warehouse is, what is task relevant data, what is data mining. I'll explain you in detail what is this task evaluation. If you look at this diagram, your database is the initial source. Your database is the initial source. And you are applying data cleaning process on this. Actually, if you look at the textbook diagram, it's not only database, you will have certain flat files also as the input. Have certain flat files also as the input. Okay. So from this, you should have the data cleaning. What is this data cleaning? And I'll tell you. This data need to be cleaned and data need to be integrated. So what is this cleaning and integration? I'll explain you in detail. Then that goes to warehouse. So on the operational data, transactional data that is available from your database, you will apply data cleaning and data integration process, and then you will send it to the warehouse. At the warehouse, you have some selection and other process happening, and you got the output as task relevant data. So that means some relevant data you're extracting from warehouse, and then you are performing data mining over. After performing data mining, you have the pattern evaluation. So the evaluated patterns are helpful for your knowledge. Okay, this is the sequence. So now I think 1001 questions arise in your mind, right? Looking at this. What is this database you are saying cleaning and saying integration? The database in data in the database is an integrated one already, right? So what is the kind of integration? Why do you need cleaning? What is this cleaning step? What is this warehouse in between? Again, warehouse is there. What is this task relevant data? Then mining, then the pattern evaluation. What is all? Right? It's quite confusing for you, right? No confusion. I'll clear everything. Okay, don't have any confusion. For this, I'll just give you an example. If you analyze this with an example, see, in my talk before, I have mentioned that data is available in databases. That is the source for you, right? Your transactional data is piling up across several years or several months or whatever it is across a time period, and it is lying waste in the cold storage. So you want to move it, you want to use it for your analysis purpose. That is, you want to extract the knowledge. What is the knowledge? We studied in your previous slides that previously unknown useful knowledge. So what is the unknown useful knowledge for you? Yes, what are the buying patterns for this? In June month, how the sales is there? How in January, how is the sale? Or during summer, how is the sale? And what is the sale of this product during different summer? Suppose you are selling your winter clothing in your stores. For this December, you want to predict how many sweaters or how many jackets or how many mufflers or how many monkey caps you want to maintain. You just want to analyze. So for that, what you will do? Past 3-4 years winter sales data you will have, right? Then 5 years ago and today, there might be change in fashion. There might be some change in material. So 5 years data may not be relevant to you because if I say 5 years ago, nobody was using a tinned food, right? You say what nonsense it is. We have all fresh vegetables available in market, cook it in no time and eat. Now in and around you have a lot of industry. A lot of jobs are there. Husband and wife going for the job. So they just get the frozen food and just do it in no time. You see, today you go to Spencer, you will get the cut vegetables. Right? It will be cut and cleaned vegetables. And you will get uh, some ready-made things also. A lot of ready-made things. Now they are seen in Spencer. 10 years ago, nobody was just looking at. Suppose green peas is there. Hardly you are buying green peas raw if it is available in December month. You are enjoying that green peas for a while and you are done with it. Never habituated to buy the frozen green peas, right? But now everybody is interested in a green peas fried rice with stuffed with something else, this, that. So the frozen green peas is a hot cake now. So they'll sell it. Why it is happening? Because there is a change in the taste and change in the trend. So you'll see last year, before last year, how the sales. and you can predict this year's sale. Similarly, the winter clothing. Last year it is huge sale, let us say. Then last year there were 100 sweaters sold. So this year if you say that, okay, I'll sell 100 sweaters, you might end up in incurring loss because last year might be very cold. There was some cold wave, let us suppose the prediction. So people purchased 100 sweaters. But this time you have to check the weather forecast for December and January. This time people say no cold at all. Probably you don't require any sweater, let us suppose. That is the weather prediction. In such case, if you stock 100 sweaters in your stores, hardly you will end up selling 3 or 4 and remaining 90 plus will be lying idle in it. It's a big loss for you. So you have to be very, very cautious and careful about it. Do you agree with me? So from the previous data, you have to apply analysis. What are all the factors that are influencing decision making? And you have to predict. So here in such case, uh, that from those patterns you will get the knowledge. So you have the database at the beginning end and the knowledge is the final output. So now what are the intermediate steps that lead from this to the knowledge? So here one thing you have to pretty much remember is for your knowledge extraction, this knowledge extraction is based on a subject. Is a subject based thing, first of all. What for you have to extract the knowledge? Because you have lot of subjects in the entire system. So your knowledge is to find out how to enhance my sales. That knowledge you want. Or you want to find out what should be my production. So your subject is production. So you have to identify on what basis you want to extract the knowledge. So you should have a specific targeted subject on which you want to extract the knowledge. That is first. So if you want to predict that, you have your database here. Okay. Then for that, or just for the sake of getting the sales knowledge or enhancement of the thing, you need to get certain parameters out of this relational database that is spread across different tables. So you cannot maintain multiple tables for your knowledge extraction. So whatever is the information that is needed, the base level information, the grain level information, you have to get from this database. You have to decide what is that grain level, base level information. Suppose if it is your sales data, the grain level information is your item quantity unit price total. So that is the grain information you have to. Okay. And that you will, I'll talk about data cleaning and integration a bit later. Okay. So that specific information that is needed for your knowledge extraction of a particular subject will be stored in your database. Okay. So you got the difference between your warehouse and the operational data. Operational data is the source of your day-to-day transaction processing. It consists of several hundreds of tables and the data is being run around. But your knowledge required is about a specific subject you want to extract knowledge. Got my point? So for this, you cannot use straight away the data that is available in the database. So you have to extract certain fields that are needed for answering your knowledge and your pattern. That data only need to be stored in a warehouse. Got it? Then once it is there in warehouse, what is again this task relevant data? Task relevant data means the data that is needed for your analysis only. That is the task relevant. Okay. So what happens is once the data is there in warehouse, can you use it straight away? Because I said, yes, the point of sale transaction is the grain level data, your rice quantity, unit price, and total price. So that means your entire transactions across this one financial year, they are being stored in your warehouse with this data format. Got my point? With this data format, because you have to separate every line here. So you have separated all the lines and you have stored the information in your warehouse. But can you extract knowledge straight away from that? Can you get the relevant data for predicting the sales of winter clothing in December? Just with this point of sales transactions, a million stored there? Can you? You cannot. Okay. For that, you have to again alter that data. You have to apply certain techniques on that data. Okay. If it is pure numerical data related just to the sales quantity or sales items or something, pure numerical data, you will go ahead with building a multi-dimensional data cube. Okay. And from that cube, you can have certain graphs drawn for depicting the actual trends. And then from there, you can extract the knowledge. That is in the southern region of India. So and so item is sold very well. In northern part, the item is not sold that well. Like from your pie chart or bar chart or whatever it is, you can finally get the data. For which you have to build a dimensional data cube. I'll show you what dimensional data cube is. Okay. So here your data warehouse consists of the basically extract the data that is needed for your decision making. The grain level data keeps in data warehouse keeps that, and you will perform some operations on that. So performing those operations of building a data cube or classification, clustering, pattern analysis, these are certain techniques you apply on the data. Those techniques are called the data mining techniques that are needed. So once you apply the mining techniques, then the data is in a form for analysis. After data mining techniques, your pattern evaluation comes in. And once it comes in, the pattern evaluation has come into picture. Then knowledge is extractable from it. That is how the evolution takes place. Now, what is this data cleaning, data integration? What are the other stuff and everything? I think I'll start in next class, because if I just give 2-3 minutes of introduction for that, not be sufficient, and better if you listen to that afresh. So tomorrow I'll have. Now you can Raise some questions or your ideas about it. Is it understandable to you, or still you need a kind of refinement, or what is the thing? Still, if you have any ambiguity, you just suggest me. I will alter my way of presentation for yourself. Down the line, the product should be useful for you. Yeah? You should understand this. That is the bottom line for the delivery. So feel free and respond to me. You need any kind of alteration in kind of expression or any kind of more examples needed. Of course, we will come across different things. I'll initially spend some time to make you understand the concept. Then we'll go ahead. Okay.
Can I consider Facebook example for this?
Facebook example is fine, but from Facebook, what is that you want to do?
So many members upload pictures in 2014 or 13.
Okay.
That is not operational at present.
Okay.
So that type of data will be stored in data warehouse.
That will be there in repositories. Okay.
I mean,
Uh,
the data class based on the time that data is stored.
no, no. Actually, it's not the data classification. It is what is you want to extract. Because for everything, you should have basically a subject. Based on the subject, you will have the information. Suppose I tell you, I'll give you another example. Your idea is to have customer retention in an insurance policy, in an insurance scheme. Okay. Let us suppose I have uh, even better than that. I tell you about a bank account. Okay. Suppose the Ingvaisha Bank just floated one account called Orange account. They said you maintain a minimum of 5,000 rupees per month as balance in the Orange account. Because of that, we will give you drafts up to some 1 lakh or 5 lakhs free of cost. That means without any charges, we will give you the things, and some transactions are free on, and some specific things they have announced. And there is no charge for that money transfer or something. Some options they say. Suppose the idea of the bank is to promote that kind of account. Okay. Suppose if you go to a temporary attender in your laboratory and ask him, please open an orange account, the bank. It is foolish because his monthly salary itself is 5,000. He will never dream of sending some 1 lakh rupees draft across something. He will not travel and he doesn't require any traveler checks for free, or he doesn't need any of such things. So if you pay for that with the all the people around, it's of no use for you. Then what is that you have to do? You have to focus on employees whose salary is around 50,000 or something plus, and who travel to utilize this kind of business transaction. If you focus on that segment, then you end up encouraging your business, right? So here is what is the knowledge you want to get from the data. That is the most important. So for that, Facebook or Twitter or whatever it is, actually from Facebook, you can make a sentiment analysis. Because in Facebook or Twitter, you will have a lot of tweets. Let us suppose uh, people were talking about recently some of the issues. Amir Khan or somebody wanted to leave the country because it has become intolerant, right? Then there are a lot of tweets for against all those things. So you can analyze all those tweets and say that yes, these many people are supporting Amir Khan, or these many people are opposing Amir Khan. And again, just not only that simply, the youth are supporting him, the middle aged are opposing him. Okay, the youth in South India are supporting him, youth in North India are opposing him, and educated are opposing him. And suppose the people who studied arts and other things, they are opposing him. The people who studied science and other things, they are encouraging. Like this, you can give a kind of analysis. Okay. But what is your aim? What is that you want to extract that drives your entire knowledge discovery process? The topmost thing is your requirement. What knowledge you want to extract. You have to be very clear with that. And the source available is the number of tweets or whatever it is that is exactly available in the report. Then rest of the entire process is being driven by the volume of data, the kind of data, complexity of data. Various things play a predominant role there. Suppose the bank wants to find out to whom we can give loans out of 100,000 applicants. Probably you require classification. Okay. Suppose the university wants to study on what are all different groups of students here, what are all their behavioral patterns towards different subjects, and we want to enhance their quality means. Perhaps you have to cluster the data. Okay. So you want to decide the buying patterns, whether milk and bread go together or not, or whether some kind of jam and bread go together better or not. So for that you have to have a pattern analysis kind of, okay, frequent pattern analysis stuff. So what kind of technique you use depends on what you need. So depends on what you need, the knowledge drives the entire process. Based on this, what data cleaning is needed, what integration is needed, what is the task relevant data, what should be the data warehouse structure, what kind of operations are needed, what mining technique is needed, what kind of pattern evaluation technique is needed. Everything is guided by your. Is it clear to you?
Can you
Please.
can you differentiate between data warehouse and task relevant data? I mean, in a bit more clear way. I mean, it's an example about the winter clothing in December in a particular place of Kakinada.
Right, right, okay.
So, for example, in a particular Kakinada in the
Mhm.
month of December, so you
Mhm.
have to use more than one database system at a time,
Okay.
both spatial and temporal database system. As you said,
No, no. Here, the spatial and temporal data system will not come. Because what happens is, yes, is a good question from your side. You want to analyze the winter clothing sales, right? Because it appears like time and these factors are there. But what happens is, in order to decide, first of all, because that comes in future anyhow, in the remaining classes we will come across. You have to, for analyzing the data, you might be having 20 years of data, but you really don't require 20 years of data. What you will do is you will decide the time frame based on the logical cohesion of this. That means the similar environment from now onwards down the line, how many years the similar environment is prevailing. So for those many years, old data only will consider. Got my point? Suppose people started using some kind of winter clothing with some specific passions from past 3 4 years. So the same trend that is running today might have started some X years ago. So from that time frame onwards, you will consider the data. Because the thing is, that's not a very rapid changing thing to make a time series analysis. Time series analysis is made where time alone is the major criteria, like your stock market. Okay. So there the temporal thing happens, and your spatial thing means it doesn't depend because the in the map Kakinada is here and all, because the environment of Kakinada is fixed, because you are talking with reference to Kakinada here only. So there you will not use temporal or spatial concepts. Okay. Here you will use the standard normal data mining concepts. Now down the line, what is that you have to consider is from now onwards, how many years back data you have to consider means you have to just see the relevance to the current day society. How much backwards you can go. To that extent, you will decide, and that data only you will take for your analysis. That is first part of your answer. Next, please ask me if you have anything other.
Data warehouse and task relevant data.
All right. This data warehouse and task and data means your data item, this is rice, your quantity, unit price, and total price. In certain cases, what happens is, suppose I tell you, I give you a better example. I want to predict for whom I have to sanction loans and for whom I should not sanction loans. Let us suppose. So the elementary level data at grain level you get in a banking example is the name of the person, his social security number or Aadhaar ID, and then his income level, his expenditure level, his debts before, right? And is he married or any dependents are there? Okay. Is he having an own house already? How stable he is? Kind of stable job. This is some kind of data that is available to you at grain level. But in the analysis, you cannot say people with 50,000 income level, only 50,000 or 50,000, 5,000 income are good at are good pay repairs. We cannot say. But what happens is you have to enhance this to a range, because your income is 10,000, 15,000, or 20,000 will be there. But you have to, uh, at the time of prediction, you have to go for a higher level of abstraction. You will say income range, right? So you will say low income group, high income group, middle income group, or again lower middle or higher middle and high income group, like depending on you will group this data. Okay, you will group this data and that group you will use for your prediction. So your income range becomes the task relevant point there, not exactly the income at grain level. Got my point? So once this data is there, you will actually transform that into higher level of abstraction. From income to income range, age to age range. Suppose your degree is BSc, somebody is BTech, graduation level or something. Because in the logic they decide the engineering graduates who are in higher income range, who own a house, they are repaying the things well. The science graduates are somebody with a low income level, not having own house, they are not repaying loans like they want to have an analysis. So that is your task relevant data. So for getting your task relevant data, you have to transform the warehouse grain level data to higher level of abstraction and data. So we will see that in depth in subsequent classes. Okay, is it clear to you? Anybody?